Hello, everyone. Welcome to the Just the Metrics podcast. Today, we are interviewing Nicolas Ochem. He's a Tezos core dev and the founder of Midl.Dev, a company providing infrastructure services.
Hi, thank you so much for having me on your podcast.
So, Tezos is one of those protocols which has undergone an extensive amount of development. Tezos has undergone 14 different upgrades, and the 15th is upcoming. So, you being one of the core members who are working on the Oxford upgrade, I would like to explore all those ideas.
Yeah, of course. Yes, it's a blockchain with on-chain governance, and on-chain governance creating an interesting dynamic between community and core team. So thank you for giving me the opportunity to delve into Oxford and the adaptive issuance discussion in particular.
Yeah. But before we go into the details of Oxford upgrade itself, this is one of the biggest discussions happening in the blockchain space, that governance or no governance, like the social governance or on-chain governance. Because if you look at protocols like Coin or Ethereum, they don't really believe in on-chain governance. And that Bitcoin and Ethereum are the two biggest protocol in the blockchain space. And they don't believe in on-chain governance. On the contrary, Tezos is very much on-chain governance focused chain. Can you elaborate on why Tezos is taking the on-chain governance path rather than an off-chain process?
Yeah, sure. So if you go to the Ethereum Foundation website, they actually have a pretty good description on why they don't believe in on-chain governance. And the arguments are in the line of essentially it is social anyway, and people will just run the node that they all agree on. So validators upgrading the software to whatever they like is a good substitute for on-chain governance. And besides, the risk of on-chain governance are that the token holders might not have the best interest of the protocol at heart, and more tokens you have, the more power you have. But in Tezos, we strongly believe in on-chain governance, and we have a good track record behind us. So if you look at the history of the votes, you can see pretty much two different behaviors. Is that the protocol upgrades have been coming from the core teams, and they contain most of the time technical improvements for which the community trusts the core devs a lot, and some economical changes. And as far as the technological improvements are concerned, the governance has always been cleared, and it's a very high bar to clear, which is a super majority of 8 of the bakers by stake and by delegation. And then when there were economical proposals put into governance, it has historically been a bit harder to reach quorum. For example, in 2021, we had the debate on liquidity baking, and that took a few cycles to get it right. But in the process of getting this right, there is a very important dynamic forming between ecosystem and core team, which means the ecosystem holds the core team strongly accountable. That's one thing. A criticism of Ethereum is that core devs do a little bit what they want and what they find interesting, and then it's take it or leave it. Another thing is, since this bar is so hard to clear, then the core team has to listen. And lastly, it prevents the threats of forks. For example, in Ethereum, you have had two sort of prominent forks. Like there was the DAO hack, and then people created Ethereum Classic, and then there was a merge, and people created proof of work Ethereum. It's each time there is something controversial. If you don't have on-chain governance, you're at risk of people forking. And then there has to be a social aggregation over the dominant form, which can be damaging to the community. On-chain governance and the governance process that we have makes this process more formal. And at the end of the day, there will be dissenters, but these dissenters in Tezos are able to disagree and commit. Say, okay, I don't like that, but 80% of the bakers by stake are fine with that, so I'm just tagging along. So on-chain governance is a way to formalize the social process in code, and several chains are doing it, and you can see different approaches to it, and it's pretty much a work in progress. The way Tezos has been operating is like only one proposal at a time, and the acceptance is spread out over a relatively long period of 2.5. So first, you choose proposals among a menu, and then there is one vote, which requires 80%, and then a pause, and then another vote for 80% supermajority, and then another pause, and then it gets activated. So in my opinion, and looking a little bit at what the alternatives are. This is a principle of on-chain governance that just works and that has allowed us to innovate at a rapid pace while still keeping the community together.
Yeah, I really understand the logic behind that because having a hard fork or a community split is a destructive event that, and then you need time to recover from it from a community side. And if you have a clear pathway to on how to move forward, then it really avoids that particular process. And 80% is a really high bar. So usually when you look at the democratic process all over the world, if you get 50% plus vote, then you win the election. I think that's a usual. I don't know. I'm not an authority on it, so I'm just understanding the way it works in some democracies. Why 80 percentage rather than 51 percentage?
The idea is that changing the protocol is a big deal, especially you replace the entire protocol wholesale. It's not like changing a little bit of it. It's like loading a brand new code. And in order to do that, there has to be a much stronger threshold than the majority. So in real world politics, not everything is 50%. If you want to change the US Constitution, for example, that's 67%. So in the same spirit, it's just a conservative value.
It's almost like a constitutional amendment.
If you look at Oxford, the first iteration of Oxford was rejected in phase 4. It would have passed if it was 50%, but it didn't clear the 80% bar. And I think a lot of people would find it fair that given the amount of discussion that it has triggered, it goes back to the drawing board and there is a clear grounds for restarting the governance in such case.
I think now we can go into the details of Oxford proposal and maybe explore the reason why it was not passed. So basically, I understand the Oxford proposal as bringing a lot of changes, especially around the staking part, like adaptive issuance, giving importance to skin in the game. And so there are like a lot of changes comes along with the Oxford proposal. Maybe you can give us a concise overview of what Oxford proposal is and what are the main changes coming along with the Oxford proposal.
Sure. So Oxford is a wholesale upgrade, so it contains a few things, including some improvement to smart rollups. However, the most prominent change in Oxford is adaptive issuance. If you look at Bitcoin, when it got created in 2000, it was, I believe, Bitcoins being generated each time there is a new block, right? Why 50? Well, Satoshi put that out of their hat. It's like a value that's there in the code because you have to put a value. Now there is some logic behind why 50 Bitcoin, but it still feels kind of arbitrary. So Tezos is 5 years old. In 2018, that was pretty much the standard practice to have a given amount of issuance at every block. However, a few other proof of stake protocols came along that got created after Tezos and therefore benefited from more lesson learned and so much and so on. So it turns out in proof of stake, you don't necessarily have to hardcode a value because you can pretty easily have access to on-chain metric that lets you decide whether or not this issuance is enough. So why do we create new coins? We create new coins for an incentive for validators to validate and obey the consensus rules and keep the protocol working. But how much is it enough for validators to be incentivized to do this job? Well, it turns out it depends. And you can measure it on chain. You can see what is the current amount that people have staked. It's just in Tezos, we have liquid staking. And in liquid staking, it's kind of a misnomer because you can stake, but then you don't put your funds at stake. You just delegate to a baker. And this baker in turn puts their funds at stake. In particular, it's today in Tezos, 10% of the delegated amount will be actually locked and frozen. So adaptive issuance, yes.
So maybe you can explain it a bit more, this liquid staking part, because I'm not exactly sure which upgrade implemented the liquid staking, because I was looking at rewards.com and they were saying 60%, almost 70% of the tokens are staked. But when you looked at it and told me, oh, that's not really accurate because as of now, only 10% of the XTC tokens are staked. So then I was a bit confused. Oh, how does it work? And a lot of people are confused like that. Maybe you can explain it, that part a bit, so that people understand why is the real staked XTC tokens are a bit lower and why do you need adaptive issuance to bring that into a higher level?
Yeah, sure. So this aggregating website like stakingrewards.com are great. And they're all about the metrics, just like a podcast. So that's excellent. However, when you compare different chains with different ways of operating, sometimes you're going to mix and match some concepts which are not exactly matching. So yeah, liquid proof of stake is a family of proof of stake protocols where the rights to produce blocks and therefore the rewards are dictated by a delegation. However, delegation is liquid. So if you hold some Tez, you delegate them to a baker, which is the name of the delegator in Tez, and the baker will pay your rewards. However, you can still move this Tez to another address. You can have them in smart contract, and this smart contract can delegate itself. So it doesn't really put this funds at stake, because putting funds at stake means they are frozen, and then you can unstake them, and then you have an unstaking period. So how do we distribute rights today in Tezos? We look at how many tokens are delegated to a baker. Then there is a limit. The bakers can only have up to 10 times their own balance delegated to them. And based on this distribution of delegation, we give rights. Based on these rights, bakers bake blocks and they get rewarded for it. So when you see on staking rewards, 70% of the tokens are staked, it means 70% of these tokens are delegated. Tezos holders have chosen a baker and they have delegated their tokens to a baker, and therefore they're getting rewards. However, when it comes to actual slashing, never happened in Tezos. Last time was 2 years ago. But if it does happen, the actual amount that gets slashed is 10% of the total amount delegated. Because again, it's a hard-coded value that made sense when Tezos was designed. But Adaptive Issuance wants to make this value floating. So the idea is like how much is security worth? The potential of slashing is what makes your coins secure. So how much appetite is there in the ecosystem to actually lock your tokens away and get rewards for that? That's what we don't know today because we have this hard-coded 10%, and that's what we will discover in Adaptive Issuance. So in Adaptive Issuance, staking becomes an explicit operation. You can go to the CLI or you can go to a wallet and you can say, I have 1,000 Tez, I want to stake 500. And this is similar to what you have on Ethereum or Polkadot. It's a more traditional approach to slashing, to staking that we have in blockchains. So then the protocol looks at how much stake is actually held in protocol right now. And there is a target of 50%. So if we are below this 50%, we give more tokens as a reward. If we are above, we give less tokens. This is how the protocol discovers the true price of security. It's a mechanism that I think has been proven in other chains.
Yep.
And the thinking is like Tezos should get it as well for various reasons.
So was there any security incident that led to the initiation of the idea of adaptive issuance, having more Tez tokens staked to increase the security of the chain?
No, Tezos has never had a large scale safety attack. What we've seen is some people getting slashed. It's essentially an accident, bad operation of the baker, but it's very rare because we take a lot of pains to ensure that slashing is not something you would do naturally, but no big safety attack.
Okay.
The motivation for adaptive issuance is fivefold, and I can refer you to the post from Arthur Brightman. Why does adaptive issuance matter for Tezos? But essentially, it's a matter of composability and then making sure that the opportunity cost of not delegating is not too important. See, with today's delegation, if you have a traditional account on the wallet, you can delegate, that's fine. But if you want to do something interesting with your Tezos, like putting it in a smart contract, a multi-sig, a liquidity pool, or whatever else you would want to do, then you transfer money to a smart contract. But then it's complicated. When you get rewards, where do they go to? Do they go to the contract? Do they go to the people who control the contract? Do they get to people who send money to the contract? So with adaptive issuance, you should not feel bad about having your Tez not delegated, right? Today, if they're not delegated, you say, oh, I'm missing out on 5%. But if you bring this issuance number down to maybe 1%, then maybe you're fine just not doing that. And if you want to earn staking rewards, then you have to lock your tokens. It's
Got it.
important to mention that under adaptive issuance, anyone can stake their tokens with a baker, which
Okay.
is familiar to what you have on Cosmos and Polkadot. And then the baker becomes responsible for not slashing. Otherwise, it's both their tokens and yours that get slashed. So it remains your tokens. It remains in your custody. However, you put them at stake with a given baker.
Okay. So going to the, so how long is the unbounding period for test tokens?
The unbonding period is 18 days, so 6 cycles.
Coming to the problem of nothing at stake, there's this big divide in blockchain space regarding slashing because there's this nothing at stake problem. There's this divide where protocols like Ethereum or Polkadot or Tezos, there is slashing. But if you look at some protocols like Avalanche, Cardano, or newer protocols like Solana or Radix, they don't have slashing. And this cannot be also divided into academic or non-academic approach because I think people like Emin Günsira has an academic background and he has basically created his own consensus algorithm, I guess. And Cardano has also this academic background. So there's this big divide between protocols in the case of nothing at stake problem, how to deal with it, and slashing or no slashing.
In Tezos, and I think in the industry consensus, I said we view slashing as essential because otherwise you get the nothing at stake problem that you are talking about. And I just personally wouldn't be confident spending time and effort and treasure in blockchain that doesn't have a slashing mechanism. I think the blockchain industry at large is still too small for any kind of meaningful safety attacks to occur. So in a nutshell, the protocol is a piece of code that everyone running a validator has agreed to uphold. And if you try to exert an unfair advantage by going and changing this code and seeing if you can get away with some things, then there has to be a mechanism that will detect such behavior and make sure that the system keeps itself safe. And it keeps itself safe by actually removing your tokens. Like the tokens that you put at stake are just being slashed. So in Tezos, it's pretty simple. If we see you produce 2 blocks at the same level, then we put them together in a denunciation operation, and the denunciation operation will be processed by the protocol. If it's valid, your money vanishes, and some of it goes to the person who included the denunciation on chain. Simply do not trust a chain which does not have that. So I'm not very familiar with the arguments of the avalanches and Solana and the like, but I just, when I looked at them, didn't find them so convincing. Essentially, if you have nothing at stake, you will get attacked eventually in the future if your protocol becomes meaningful enough. And a blockchain has to stand the test of time. Tezos has to the test of time for 5 years without any meaningful safety attack. We want to make sure they don't happen, and having slashing is the only way we know to not make them happen.
I have seen the arguments from both sides. While I was listening to a podcast, and there was this argument from Sriram Kannan, who designed the restaking protocol on Ethereum, and he was for slashing. And I think only time will tell what is the correct approach. But as of now, we are sometimes seeing people who does not intend to attack also get slashed. It's mostly some technical mistakes. Is it legitimate to define those as attacks or like some technical mistakes leading to slashing?
Well, it turns out you have a metric again. You can see which percentage of the stake is equivocating at a given time. And if you have like 0.3% of the stake, it's probably an accident.
Okay.
If you have like 25% of the stake equivocating, which brings you very close to the 33% threshold, where under TenderMint, the chain will stop, then it's probably an attack and you should do something about it. So we don't have that in Tezos yet. The slashing is like a constant value, but it's something we could integrate. Like Issuance has this concept of adaptive slashing, if you like. So a small problem in the chain means small slashing. A big problem in the chain means we start to destroy money at a high rate just to protect what we have. It's like an immune system. Sometimes your immune system can kill you, and there are ways to prevent that, to fine tune it, to make it just right.
Yeah, not that it becomes as you said, like an autoimmune response. In this concept of adaptive issuance, you are also bringing some changes to the way slashing works. So what is different in adaptive issuance?
Well, the changes that are brought to slashing are a consequence of the fact that now we have this new concept of staker. So today we have a baker and we have delegator, right? Two different identities. We're bringing in a third one, which is a staker. So being a staker is like being a baker. You don't actually run the hardware. You stake your tokens with a baker. They remain in your possession, but they're at risk of slashing. And that's why we have to change slashing. It's a technical change. So today in Tezos, when you slash, you only slash one account, the baker's account. If and when adaptive issuance becomes activated, then you have to distribute the slash between the baker and their stakers. And it's not the first time there's been changes to staking, but to slashing, but the debate around adaptive issuance has brought extra scrutiny on the slashing mechanism. And some delegators like Everstake have claimed that it's probably too severe. And after consideration, we have brought this down for the future upcoming proposal. So 7% of what's at stake is slashed each time you bake a faulty block versus 11% previously. So when I say faulty block, I mean mostly double baking two blocks at the same time. So that's what's being slashed 7%.
Okay. And one of the other things that is being changed with adaptive issuance is skin in the game. So the way I understand it, Baker has a limit to accumulate a stake 10x to his own stake. And now it is being reduced to 5x. That means if you had like 10,000 XGC, you can get a stake up to 100,000 XGC. And post adaptive issuance implementation, if you have 10,000 XGC as a Baker, you can accumulate a stake of up to 50,000 XGC. So why this change?
So we are introducing a third concept of stake. Recall that today we have bakers and delegators, and maybe if AI activates, we'll have baker, staker, and delegator. So the ratio of baker to delegator is not changing. It's still 1-10. But the ratio of baker to staker is 1-5. So meaning if I have 10,000 tests, I can have up to 40,000 tests of third-party stake and up to 90,000 tests of delegation. And whatever goes over the stake is considered delegation. And whatever goes over the delegation has no effect. And that's actually an important concept that we don't have anywhere else in the blockchain. To my knowledge, it's a very powerful decentralization force, because if you're a large baker, you can only grow as big as your delegations and your stake. And that prevents like concentration of stake. It's like, you have sometimes network effects. So if there is a popular baker that accepts stakers and they could accept an unlimited amount of stakers, then suddenly they become too important for the good of the chain. So this mechanism prevents that. I should probably mention that we could have totally replaced the concept of delegator with the concept of staker, but we chose to keep it just because it's been important for governance. So when you delegate, you also delegate you voting to the baker. And there is something that we have here that we don't want to lose. Not everyone will be comfortable staking and putting their Tez at risk. Some people just like to delegate. So therefore, if you delegate, under adaptive issuance, you still gain something, but it's less than staking. For the entire chain, 2/3 of the rewards go to staking, 1/3 goes to delegation.
So now you are combining different factors like slashing plus skin in the game and different rewards for delegators and stakers, and now having a locking period of almost like 2.5, 3 weeks. What we have observed in protocols where tokens are locked for a while, the liquid derivative tokens start to play a role. If you look at Ethereum, you have a Lido ETH token, on Pool has its own liquid staking token, and same with Atom. Atom also has it has an unbound period of 21 days. So there are different staking providers providing different kind of tokens. And if you look at Ethereum space, what we have seen is that which is conglomerate of different kind of staking providers, but a permissioned kind of staking provider becomes a centralizing force in Ethereum. And as of now, there are like a lot of discussions on how to limit the growth of Lido because it's almost reaching 33% right now. So is there also liquid staking derivative also being implemented at the same time?
Yeah, as the concerns for Lido becoming too big are valid in my view. And it's especially the emergence of something systematically important that has a net multi-sig, because Lido has a multi-sig. And we just want to keep things governed by governance and design the protocols so that we don't see the emergence of liquid staking derivatives. So for once on Ethereum today, there is no delegation. That's probably the main driver for LSD tokens such as Lido, is that you simply cannot delegate. You either run your hardware or you out of rewards totally. But then, of course, the fact that you can issue a token which represents the staking derivative has a lot of adverse effects. So there is a lot of value in the Ethereum ecosystem. So it's fine to have this multitude of tokens. But in Tezos, we try to avoid that. I think it's a key differentiator and an important aspect that blockchain finally realized is like we want the base token to be a store of value, medium of exchange, and the emergence of another token that's systematically important can affect that. So in the initial proposal of adaptive issuance, only regular accounts can stake, right? Not accounts owned by a smart contract. So therefore, that prevents the emergence of liquid staking derivatives. So for once, you don't really need it because you can stake with a different baker. So the only thing you gain with a liquid staking derivative is forego the unfreezing period and be able to exit straight away. So yeah, with the agreement of the community, we think it's not something that should happen on Tezos. So on the other hand, we want smart contracts to be able to stake. So there are discussions of having a small whitelist of contracts that can also stake their tokens, but not any contract. So you cannot build a liquid staking derivative platform on Tezos with a multi-sig and a token, because we think then would have the same problems as Ethereum. Then,
Okay.
of course, at the end of the day, it's up to the community. The community might be excited in seeing Lido on Tezos with a Lido-like token that you can then trade and provide liquidity for. It's always exciting to have a new token. But I think at the end of the day, it comes back to bite you. And even on Ethereum, I think this effervescence of tokens, like everything has a token, every piece of infrastructure has its own token. And then people go ahead and speculate on it based on vibes, basically, is going to come to bite them.
Okay, got it. So I think we have discussed enough about adaptive issuance and people will get a detailed idea about what adaptive issuance is bringing. One thing I have noticed in Tezos is that Tezos is the only blockchain which has transformed from a proof of stake Nakamoto style consensus protocol to a proof of stake pBFT kind of consensus protocol. I forgot the name of the old consensus protocol, but the newer one is TenderBake, which is similar to the Tendermint of Cosmos ecosystem. So what was the reason for this change? Because you started with a different assumption and in between it changed and then you moved to a basically different consensus protocol. What was the reason for that?
In general, we like to say in Tezos, your blockchain is our testnet. And Tezos has a certain age and consensus, what's it established by the time Tezos was designed. And then again, same thing then adaptive issuance. The industry at large found that pBFT style consensus is better because it provides finality. Nakamoto, you're never totally sure that your transaction is final. You just, if you wait long enough, then the probability of your transaction not being final becomes vanishingly small, and then it's probably fine. That's why typically, if you buy something with Bitcoin, people say, yeah, wait an hour. It's ridiculous that you have to wait an hour. But what deterministic finality brings you is like the chain will only build the next block if it has seen a significant amount of attestations for the previous block. And that's a very powerful concept. So blocks have 15 seconds on Tezos. So it means that maximum 45 seconds after doing something on chain, you either know whether it worked or it didn't. And 45 seconds is still too long. We are hopefully bringing this down, but it's very strong. So thanks to our on-chain governance, and excellent team of OCaml developers, we were able to switch the consensus at the Ithaka upgrade, and that went well. And now we can build a lot of things based on this two-block finality that we have.
I have heard that eventually Tezos is looking to reducing the finality to a block time of 5 seconds. So if it's 3-block finality, it will be like 15 seconds eventually, I guess.
But yeah, block time of 5 seconds has significant difficulties. But yeah, I think that we have to go under 12 seconds for starters to just have these bragging rights that we have faster than Ethereum. And then beyond that, up to the limit of like circumference of the Earth dictates to our design.
Yeah. So moving on to the next topic of how you describe test token, because there is this difference in perceptions of different blockchain for their base token. I have heard opinions from Anatoly Yakovenko that Sol token is not really a store of value or like money the way ETH community sees ETH. And if you look at ETH, how it evolved differently in comparison to Bitcoin, it has no supply cap, but it is also seen as money in the sense that the Ethereum ecosystem would like to see ETH accruing value, and that being a biggest value proposition, and that being one of the driving principles in that ecosystem. So how do you see XDC? Is it something similar to the way Solana founders see it, or is it something similar to the way Bitcoin or Ethereum sees the base token of the blockchain?
Yeah, Tezos in its design has strong inspirations from Bitcoin. And the way I say it is a store of value, a medium of exchange. So pretty much on the Bitcoin camp rather than the Solana camp here. And Ethereum has come up with the concept of ultrasound money, meaning like there is no supply cap, but they should also actively burn the token based on usage, just to make sure that it keeps accumulating value. Well, that has been a successful strategy. And a lot of people have onboarded Ethereum because they were excited about the ultrasound money meme. And I think there is some danger into that as well, in that if you have an anticipation that your token is going to be more valuable over time, then you have a tendency to not make productive use of it, which can in turn hurt the value of your token. So the opposite of what you are aiming for. So I think going back to adaptive issuance, it is sound money, not ultrasound money, making sure that you still get rewards while staking, but not enough that staking is the thing you must do. So staking is something you can do, but better use utils for buying cool art or speculating on DeFi, or maybe even finding real world usage for DeFi or whatever else you can imagine. I think adoption right now is close to zero. Another thing I would say is do not anticipate revenue of your base token coming from fees. So fees are important because, as you said, and as the Solana founder said, it's a DDoS prevention mechanism. And sure, you need every transaction to pay a fee to not overwhelm the system, but you need this fee to be very small so your system can scale. And even if there is no current need for the scale, because if you look at test blocks, they're not full today. So fee revenue on Tezos is meaningless. But if you consider some people with a novel idea looking for a blockchain, they're going to ask, is your blockchain going to scale? So of course, that's why we have low fees. That's why we have rollups that are in the works. There is a potential to increase the usability of the platform to things we can't imagine yet, like a lot more users and a lot more complicated processing on the distributed ledger. But then, of course, that means that currently the fees are meaningless. And holding Tez doesn't mean you can expect rewards from fees. No, holding Tez means that you believe in the platform that we are building, the on-chain governance, the way that we are resilient to various hacks. We haven't been hacked in the past 5 years. And that's what's valuable. This would translate into the reasons why you would hold Tez.
Okay, got it. So moving on to the topic of scalability, because this is one of the most talked about topic in the whole blockchain ecosystem. And there's this whole idea of blockchain trilemma and how different blockchains are trying to solve it. Tezos is going for the rollup centric roadmap, which is very similar to Ethereum's. rollup-centric approach. So what is the rationale for Tezos taking a rollup-centric approach?
Well, the reasoning comes from thinking a lot about it and reading the science, pretty much landing on the same conclusion than the researchers at Ethereum, is that rollups is the way to scale. It is just apparent to us the rollups are the way to scale your chain. Basically realize that there is only a finite amount of computation that can happen in every block, and there is only a finite amount of storage that can be stored in every block. So you look at ways to go beyond that. And the way to go beyond that is to have more computation, but this computation is done off the main chain, but can still be escalated to the main chain and liable to consensus shall a disagreement occur on the layer 2. So yeah, this is what we're doing. And so there is not a lot of buzz in the crypto ecosystem at large about the Tezos solutions for scaling with layer 2s. But in my opinion, it is the best superior solution out there just because it has fraud proofs enshrined in the layer 1. So in Tezos, we enshrine liberal. There are good and bad parts to it, but mostly the good part is that we have this dynamic of updates every few months, which means we have some practice of safely adding new features to the protocol. And this new feature that comes with rollups is fraud proofs from day one. And the way a fraud proof works is that you have a whole bunch of computation going on your layer 2. Well, this computation runs in a special virtual machine. And when you create a rollup, you commit your rollup kernel, which is basically the rules of your rollup. And you put 10,000 test bond. It's like, I want the rollup to do this. And if it ever deviates from this, then I will lose my bond. And then anyone can also publish a bond and starts pushing data to this rollup as long as it's compliant with the rules. So no multi-sig. If the rollup creator tries to rug their users, they can't because it's not compliant with the kernel as it was published. And if they try to do that, anyone else can just submit the actual computation together with a fraud proof. And the fraud proof mechanism is what you call the refutation game. So it's like a game of ping pong between the bad and the good party. And it will converge from a large computation, which is too big for the L1 to process, to smaller and smaller chunks until you get to the problem. And whoever is lying is slashed and the other one carries on with the rollup. So this is not a novel mechanism and we didn't invent it or anything, but today Ethereum doesn't have that. Ethereum rollups have to be trusted by various multi-sigs and they are not implementing that fast enough. I mean, not saying it's not going to come, but there is clearly an advantage if in deploying your rollup on Tezos today, in that you have these fraud proofs and the same safety guarantees on the L1, just with much bigger throughput.
Yeah, in Ethereum roadmap, they have this concept of trading wheels for their rollups, and most of the rollups are using these trading wheels effectively in the sense that most of them are very much centralized using multisigs for upgrades and basically very much centralized the way it works right now. There's a website called, it clearly shows which rollup is in which part of development, but it seems like Tezos rollups are much more decentralized. They are implemented this concept of enshrined rollups. There, the protocol is enshrined in the layer 1, not dependent on some kind of multi-sigs for upgrades or governance. But there is this one problem with rollups is that some people argue that the killer app of blockchain is a layer 1, a composable ecosystem of dApps on a layer 1. That means seamless interaction between these dApps on top of a layer 1 blockchain. That itself is the killer app because that's why Ethereum layer 1 succeeded and it has this big first mover advantage because it has enabled this atomic composability between different kinds of dApps on its ecosystem. And that eventually got so big. And then they started this very elaborate roadmap of scaling that particular L1. So what do you think about that? Like, isn't the concept of rollup having very isolated databases on top of a single layer 1 is actually fracturing the liquidity or the activity on L1 to small isolated parts on top of this L1?
Yeah, you're absolutely right that rollups naturally comes with some friction. Especially in the case of Tezos, we've had the optimistic route. So roughly speaking, there are two categories. There is optimistic and there is ZK rollup. we have found in Tezos, we have a very good cryptography team at Nomadic Labs. And what they say is basically ZK is mostly a hype, and doing the things you can do with ZK, doing the things you can do with optimistic, with a ZK rollup is really prohibitive. So we went the optimistic route. The optimistic route has issues, in meaning that if you want to make a transfer from the layer 1 to the layer 2, it's instant. But a transfer back from the layer 2 to a layer 1 or to another layer 2 takes a refutation period of 7 days, where you have to give some time for people to potentially denounce that you did something faulty before giving back the token. So yeah, it is an impediment. And of course, the UX issue of having rollups is not great. So yeah, there is this blog post from Vitalik Buterin where he's showing a screenshot of his Brave wallet where he has a ETH token, but these ETH tokens are on the various rollups. And imagine a first-time crypto user coming and seeing that interface, they would basically scream internally. So we have all of that in mind in Tezos. So for starters, yeah, the emphasis on a given token, like the test token will be the base tokens for rollups, hopefully. Anyone can deploy a rollup with its own token, but we try to encourage composability based on tests. And also the fact that you have to wait 7 days can be mitigated with trusted bridges. I mean, bridge is a scary thing, but there is nothing wrong with using a trusted intermediary to move from a rollup to another rather than waiting this 7 days. And lastly, what we're actively building is ultra high throughput rollup. It's like the problem of rollup composability goes away if you have only one big rollup. And that's what we are shooting for in the medium term.
So I have looked into this concept of ultra high throughput rollup. So the way I describe it from a very high level point of view is that you are planning to build a Solana-like platform with a very high throughput on top of the layer 1 Tezos chain. But you also include capabilities like atomic composability between protocols and also the capability of deploying protocols using popular programming languages. You can actually use different kind of programming languages. So that's how I understand it. Like, how would you describe it, or am I correct?
Yeah, I think you're basically correct. So if you look at the criticism of Solana and all other blockchains which have a very high throughput, like the Move family of blockchains up to Sansui, that there is a trilemma, and you necessarily sacrifice decentralization by going for high throughput. And that is true because the Solana node has several jobs, which is to keep the consensus, but also process all this very high throughput transaction. And the Solana validator ecosystem is pretty centralized. And when it comes to Aptos and Sui, it's even worse because the barrier of entry to become a validator is so high. It's ridiculous. So as we scale up, there are a few very important properties of the layer 1 we want to maintain, meaning low barrier of entry. It's 6,000 Tez to become a validator, which is not trivial, but also not ridiculous in the sense that we still have a lot of people becoming bakers like out of the blue in Tezos today. That's something that just regularly happens. And on the other hand, the hardware requirements for running the layer 1 consensus should be small. Like you should ideally bake on a small computer, Raspberry Pi, maybe a Raspberry Pi 5, which just came out. You are able to run a Tezos baker on it. I hope so. I hope we try. Pretty excited about baking on Raspberry Pi. So we don't want to lose that as we scale up. But if we have this rollup with fraud proof that I described, and if we make the mechanism better, then why not split the setup in two, like a small validator that's only responsible for consensus, and then you can go nuts and have very nice, very big Solana style 1 gig of RAM server blades to run your rollup. Because consensus, you don't have to establish consensus at the rollup level. You only need one as the rollup actor. You can have many, but in theory, one is enough. And because you have fraud proofs, even though the computations are very big, if there is anything untoward going on in your big machine doing ultra high throughput, there is still the ability to quickly escalate to the layer 1 node and punish the person who's not acting corresponding to the rules. So the ultra high throughput is a very powerful concept. And I like how you put it. It can reconcile like the devs who expect like a Solana-like experience of everything being blazing fast.
Okay.
And the typical expectation of strong decentralization and no compromises. So
Okay.
right now, the big focus is on EVM. Because, fact of the matter is a lot of devs prefer Solidity and they would rather go to a Solidity chain. So our smart contract language is Michelson. It doesn't have as much usability. We are providing Solidity, but we hope that in the 2-3 year horizon, we would have one big rollup that can do Solidity. It can do Michelson. And anyone can deploy something on it. And it even goes beyond the constrained environments of a smart contract language as we understand it today to a very big general purpose code base in Python or Node, for example, with a few hooks to the economic parts, which are probably some very well crafted, well edited libraries. But on top of that, you can build very large executable, very big apps that you can only build in the Web 2 today. You could do that on ultra high throughput.
That means safety, the parts that deals with money of that particular dApp or protocol can be dealt with Michelson, which is a much more secure kind of language compared to something like Solidity, which is a bit complicated. And because we always see big hacks happening on Ethereum. And one of the reasons why it happens is because of the way the EVM works, and it can create problems. So having this ultra high throughput with all different kind of languages, security becomes an issue, but you are saying that it can be dealt with by dealing with the parts that deal with the actual money part of the protocol in a much more secure language or programming model.
Yeah. I mean, we are working on Solidity support. Solidity support will be there, and Solidity has won so far, despite all its problems. So it is possible to write Solidity code that's safe. It's just there are a lot of things you need to be aware of, but that's what people are doing. So it's totally fine. If you have a game, for example, you can just build a cool game. The parts of the game where you deal with something that's not fungible or something that actual money transaction, like getting a new weapon for your soldier or whatever, then you can touch on the Solidity code or Michelson code or whatever interact with the actual money. But for the rest, it's pretty much traditional developer experience that like millions of developers across the globe would feel at home with.
Oh, yeah. So one of the things with blockchain development is that considering Bitcoin being live for almost 15 years right now, and Ethereum white paper got released in 2013. So it's almost a decade since the concept of Ethereum is live. But if you look at the developer ecosystem on blockchains, it's a bit sparse. So there was this developer report by Electric Capital, and they have their own method of counting monthly active developers in the blockchain ecosystem. Generally, the idea is that chains has not seen adoption because these developer numbers are very low, even considering them having like 1,889 monthly active developers.
Yeah, adoption is key. And I fully agree with your assessment. Like, it has not delivered. Like, we have not delivered. And if you look at even Google searches for blockchain, they are back to 2019 levels. It's just a big missed opportunity, and adoption is super important. It's the only thing that matters. I mean, we've been talking about adaptive issuance, scaling, and for me, I'm a dev and I love to look at metrics like you do, so I care a lot about that, but it doesn't really matter in the face of adoption. I deal with the core of the protocol, but what I can tell you is there is a Tezos Foundation and largely two companies, Nomadic Labs and Trilitech in recent London, which are trying to get metrics-based approach to adoption as well, just to try to do the right things and see what are our goals. There can be a disconnect sometimes between core devs and the rest of the ecosystem, because core devs want to build a protocol and they have these overarching goals of decentralization and consensus, without which we have nothing. But how do we enable this business to exist and be sustainable? is what the whole industry is searching for. We are looking for that. But yeah, in Tezos, we distinguish ourselves with our art scene. We recently announced partnerships with Musée d'Orsay, which is the second most prominent museum in France, and MoMA in New York City. So pretty large and well-known museums. So they are issuing NFTs on Tezos today. Our DeFi ecosystem has a lot to offer. If you look at weekly active users on Tezos, today we are like at 6,000, give or take. I can tell you that most of this usage is genuine. It's not farm bots, right? It's not people chasing airdrops like you see on other blockchains. We have a small dedicated user base, trying very hard to grow it. And I think, yeah, we can always do better, but the blockchain industry as a whole has to be focused on adoption. The real question is, how do we address the 99.9% of people who are not there yet? Would they care about issuance, or would they care about the novel use cases that we don't have?
So that's the question. You are pursuing the rollup centric roadmap with ultimately ultra high throughput rollup that can enable very popular programming languages and making the base layer as decentralized as possible. So you are aiming at all the right things. So hopefully that would work out. Regarding this question of one honest party is enough to make a high throughput rollup secure, how exactly that works? I know it involves fraud proofs and submitting these fraud proofs to refute any kind of false transactions. But can you elaborate on this idea that one honest party is enough to make a rollup secure?
Yeah, it's a matter of defining the rules in advance. So when you create a rollup, as part of the creation of your rollup, you push a kernel. This kernel will actually dictate the rules of your rollup. So, for example, management of tokens within the rollup. If you build a very basic rollup which is only doing transactions, like instead of exchanging tokens on the layer 1, you exchange tokens on the layer 2. That's a nice simple example. Well, if the rules governing the token transfers on the layer 2 are in the kernel, so if I'm the only one on the internet running such rollup, and I decide that suddenly all the tokens belong to my wallet, right? I could just publish an invalid state transition, but then anyone else can refute it. Let's say this state transaction is invalid because you've done a transfer which is not supported according to the rules of the kernel. And therefore, the refutation game begins, and then the person who originally pushed this bad transfer is slashed, and this invalid state transaction is not accepted as canonical by the chain, and everything is good. We also have this concept of tickets on Tezos. So, on Ethereum, you have ERC20 standard, which is very widely adopted. And I like to describe it as an Excel sheet on chain. It's like you keep track of which Ethereum address has which tokens, but whoever publishes this ERC20 contract may retain rights to edit any cell of the sheet. While tickets are just like this. They represent anything you want, but they belong to you. And any action on these tokens will need to be signed by you, the owner, and no one has admin control over the contract. Now, our token standards in Tezos today are still largely based on ERC style contract management, but for Rollup, we want them to be ticket centric. It's also Nozachi, Toto, Aptos, and Sui also have the same concept. But I think it's very important to preserve decentralization.
I have heard this concept, like different blockchains have different concepts for dealing with the token standards. Some have this native token standards, and that allows a different kind of property. And Tezos, as you said, has a concept of tickets. So it's interesting to see how diverse this is and how people try to deal this problem using different kind of solutions. And finally, if I like coming back to the first topic, we actually talked about the Oxford upgrade and adaptive issuance. The first proposal for Oxford upgrades failed to go through the governance process. That means it was rejected. Why do you think, like, if you look at the history of upgrades of Tezos, every technical upgrade that somehow helped improve the scalability of the system or some technical thing that has nothing to do with the economics of the test token or how the staking works went pretty smoothly through the governance process and just passed. But whenever you see some upgrades that deal with the economics or the staking or how the economics of the protocol work, then you see a different kind of behavior from the participants in the governance. Why do you think is that?
So it comes down to what bakers think they can influence. I mean, we have a history of successful technical upgrades, or at least nothing really went terribly wrong without technical upgrades. So people judge future behavior based on past behavior and think that if you have a purely technical upgrade, it's probably fine and probably safe. If you have a upgrade that contains a crypto economics change, then that's where people will really engage the governance, because it affects their earnings as a baker, as a custodian. It also affects what they can do with these tokens. So this is why we see a much bigger debate, like vigorous debate. We had that with baking, and we've had on our Tezos Agora forum, very long-ranging discussion and very civil and cordial discussion, I must say, compared to what we had in the past about adaptive issuance. And people, it makes sense that bakers would be much more engaged with a crypto economic change than a purely technical change. Now, to be fair, Oxford One had a few non-critical bugs, and some people made the point that, why not take a step back and just fix these bugs, even though it would probably have been fine, not caused any harm to the protocol. But the argument that we should have protocol bug-free kind of resonates with me, especially, I mean, if you're going to a 2 months governance cycle, probably during this time you'll find bugs, but then the protocol being voted in is a hash of the code. So if you change one character in the code, it's a brand new protocol. And technically, you have to start over. Sometimes you may not want that. So from a technical point of view, Oxford One would have been fine. So some people may have used the bug as an excuse, while in fact they object to it on other grounds. We don't know. We will know pretty soon, I guess. The idea was like we would have a toggle vote. So the Oxford would not have enabled adaptive issuance. It would have enabled the ability for bakers to vote on it as a separate process that doesn't require a wholesale change of the protocol. And whenever we reach a threshold in this internal vote, then adaptive issuance will activate. But despite that, some people have decided that they don't trust this second mechanism. They only trust the first, the base governance, and therefore they might have rejected Oxford on the basis of this.
Yeah, but it's interesting to see this behavior, like the participant behavior, when it's something to do with the economics of the protocol and purely technical upgrade. That's interesting, and I think as Tezos gets more and more bigger, governance will be an important venue to watch, because keeping the chain together and moving forward is basically the concept of Tezos on chain governance rather than hard forking. So this is very interesting to watch this development, actually.
Oh, yeah. And actually, I think blockchains who don't have on-chain governance are in big trouble moving forward.
So thank you for taking the time, Nicola, for this conversation.
Yes, thanks so much. And I want to thank you for making these detailed reports about Tezos and other blockchains. I think it's always useful to take the metric-based approach and keep doing that.
Thank you. So if you watch this far, you will like more content in our news platform, Just the Metrics. So please subscribe to the channel and subscribe to the newsletter. Thank you.